Hello, once again, you all are welcome in my channel. Today we are going to discuss a very important machine learning algorithm, that is logistic regression, and I hope you like this. So I'll request you to watch till end so that you get an insight into this algorithm. So let us begin with the first logistic regression model. This is the basically how it is different from the linear regression model. In logistic regression model, basically it is a classification algorithm by which we can classify the object into yes or no, like happy or sad. Here it is shown there are several inputs. So on the basis of this, here we apply a logistic regression model. It will segregate the number of persons who are happy or number of persons who are sad. So logistic regression is nothing but it's a classification algorithm through which we can classify the objects into different categories, generally 0 and 1, or you may say happy and sad, as shown here. So logistic regression was used in the biological scientists in the early 20th century. It was then used in many social sciences application. Logistic regression is used when the dependent variable target is categorical. For example, to predict whether an email is spam or not. If it is a spam, then 1 is shown. If it is not a spam, then 0 is shown. Like say I'm already tell in logistic regression it is based on the binary, where 1 stands for positive and 0 stands for negative. Similarly, whether the tumor is malignant, then if it is 1 it means it is, otherwise if it is not, then it is 0. Similarly, consider a scenario where we need to classify whether an email is a spam or not. If we use linear regression for this problem, there is a need for setting up a threshold based on which classification can be done. And why not we apply the linear regression here? It is because, say if the actual class is malignant, predicted continuous value is 0.4 and the threshold value is 0.5, then the data points will be classified as not malignant, which can lead to a serious consequence in the real time. Let us suppose a patient has a value 0.4, and for a 0.4 value, if we consider it 0, it means the patient do not have malignant cancer, so it maybe sometimes leads to a dangerous results. That's why linear regression algorithm is not applicable for the classification. For example, from this example, it can be inferred that linear regression is not suitable, that I already tell you. Linear regression is unbounded, and this brings logistic regression into picture. Their values strictly range from 0 or 1, means it is 0 if the cancer patient has not a cancer, then it is 0. If the patient is suffered from the cancer, then it is 1. So in logistic regression, the function that we use behind is sigmoid function. I think you understand the sigmoid function, and you have to be go into the detail of the sigmoid function in mathematics also. It is basically used for classify the things into two groups. Sigmoid function here, the value is whenever it is 0.5 more than 0.5, it is considered to be 1, or positive side. If it is less than 0.5, then it is considered to be the negative side or 0. So in this way, the logistic regression can be classified into three groups. Number 1 is binary logistic regression. In this, the categorical responses has only two possible outcomes, like spam, either it is spam or not. But in multi-nominal logistic regression, 3 or more categories without ordering, for example predicting whether food is veg, non-veg or vegan, it can be done with the help of multi-nominal logistic regression. Then there is another third form of logistic regression, that is what we call ordinal logistic regression. 3 or more category with the ordering, for example movie rating from 1 to 5, you have to rate it from 1, 2, 3, 4, 5. Then in that kind of problems, we used ordinal logistic regression. In this example, in the today's live example, I'll show you the binary logistic regression, but in the subsequent classes I will cover multi-nominal and ordinal logistic regression as well. So let us begin with the practical example. For practical example, to do the practical example, we should have to go to the Google first, and I'm using here Google Colab. You can use IBM or any one of the platform, either IBM tool, Google Colab, or you may use Anaconda as well for a Jupyter notebook. But here I am using Google Colab. What you have to do, you have to just go to the Google Colab, and here you have to create one more class notebook. Here I am just creating it for you. You just have to go to the file and new Python 3 notebook you have to be created. And for this I am using the one of the data available in the Kaggle competition website. So I put the link of the data whatsoever I have. You have to add it into this folder. You have to click it on this folder, and it will take some time depending upon the internet connection. Yeah, so now here you have to upload the data. You have to go to the upload. For the sake of convenience, I have this Framingham data set with me. I will just create it, click it, and here it will remind you that this is only available for this runtime. Whenever you have to reloaded it in the next time, whenever you reconnected it with next time, you have to reload it the data. Then I'll click it OK, no problem. So now you see Framingham CSV file is here. So what we are going to do today, I'll tell you in brief. First, I am taking an example where WHO has estimated 12 million deaths occur worldwide every year due to the heart diseases. Half the deaths in the United States and other developed countries are due to the cardiovascular diseases. The early prognosis of cardiovascular disease can aid in the making decisions on lifestyle changes in high-risk patients and in turn reduce the complications. This research intends to pinpoint the most relevant risk factors of the heart disease as well as predict the overall risk using logistic regression. Basically here at the end we see how many number of patients are suffer from cardiovascular disease due to smoking or some other reasons. We will see as the question progress. So as we did earlier, similarly the very first step is to add the libraries. So I am here adding the libraries. So I added the libraries like this. You just have to import the pandas as PD, numpy as npy, and stats model, that is an API, and similarly sciencepy.stats for doing the statistical calculation, matplotlib for drawing graphs, cmon, this is also help for drawing graphs, sklearn.matrix for calculating the confusion matrix, and matplotlib. So these are the libraries which are very important and necessary to do the logistic regression. So we'll move forward. So the very first step is the data preparation. The dataset is publicly available on Kaggle website, and it is form of ongoing cardiovascular study on resident of the town of Framingham. The classification goal is to predict whether the patient has 10-year risk of future coronary heart disease. That is in short form it is called CHD, coronary heart disease. The dataset provides the patient information. It includes over 4,000 records and 15 attributes. So let's see what the data is actually consist of. So we have to, I am just creating one code line here and creating a heart underscore df as a data from this CSV. So this is if it is not right, it means this data is fetched here with the data frame of heart underscore df. Now here heart, if we want to see the heads of the dataset, so you can do it with this command. These are the dataset heads, and with heads we will have 5. So these are the heads. See here the education, I think this is education is one of the unnecessary column here. So I'll delete these columns. How this can be done? For this you have to just again create one more code line. This can be easily done with the help of this command, heart underscore df.drop. With df.drop you can drop any one of the column which is not needed. since education I found it is have a very least impact of our study, so I'll go to delete this. And once I run this command, this column get deleted. If you want to check it, you just have to copy this cell again and pasted it here. Since it is deleted, okay, so if I check the heads once again, now this time this education column get will not be appeared. See here, this is deleted because I'll drop this with this command. So we'll move forward, and there, as seen in the heads, there is a one column that is what we call male. Rather than this male, what I want to do, I'll change this heading with sex male. How it can be done? This can be done by using this command hurt underscore df dot rename. By using the rename, I am renaming the column name male with the sex male. Once I run this can be automatically done. If you want to see whether this change get done or not, this can be done by checking the heads once again. Now I am checking the heads once again. When I am checking the heads, see this column name male get renamed into sex male. This command is very important. Sometimes it is used widely for changing the name of the heads or this headers. So now move forward. Now I am telling you how to handle the missing values. First of all, we have to check how many missing values are there. So for this is a command hurt dot underscore df dot is null dot sum. This will gives you all the heads with the null values. See, cigarettes per day, that has 29 non-null values. Similarly, BP meds, these are the values whatsoever indicated are non-zero, means non-null values. They have some ambiguous data in these columns. So how to handle these columns, I will tell you. So with this function count is equal to 0 for I in hurt df, that is the name of the dataset. If I is greater than 0, I am counting how many zeros are totally present in the this, how many non-null values are totally present. We will, when I clicked it, this will tell us there are total 489 null values. So 489 null values out of 5000 6000 is very less. So we can we can delete these values or drop these values. How we can do this, I'll tell you. For that, you just have to run this command. That is drop na. With this command, once you run this, you will find there is no null value left, because you deleted the values which is not null. Now I am once again checking how many null values are left. So once I click this time all zeros, it means there is no null values left. So this how, because I already deleted whatsoever I dropped it, whatsoever values which are non-null, I'll drop that. Now our data is having no null values. So we'll move forward. If you want to see the histograms of data frame features, and you can do it with this command. This is very easy, and once you run this, you can see the histogram of all the distributions with all the parameters with each other, like cigarettes per day distribution you see, and sex male distribution, age distribution, BMI, BPI. This is a basically histogram view of all the columns present. So this is again very important to understand. So we'll move forward. So in this heart underscore df data frame, we are now want to count how many 10-year CSD, that is cardio disease, having the age 10 years values. So we want to just check it. So once I run this, I have a count. There are total 3179 persons which do not have this cardio disease, and but one, that is 572 number of peoples having the cardiovascular disease and having the age 10 years. So this is very important to get insight into the data. Now we will move forward. The same thing can be graphically represented with this command snplot. You can see the same 3,179% have zero cardiovascular disease, and 572 having the positive cardiovascular disease. So we'll move forward. Logistic regression is a type of regression analysis in statistics used for prediction of outcomes of a categorical dependent variable from a set of predictor or independent variables. In logistic regression, the dependent variable is always binary. Logistic regression is mainly used for prediction and also calculating the probability of success. What it means? This I already told you. Logistic regression is basically used for classification. Classify the data into two sets, 0 and 1. Means the people having suffering from cardio heart disease or not. So now this is the time to separate the data into test and train sets. So this is a command. By this, when I run this will segregated the data into train and test, and here we are using the splitting size in the ratio of 20%. It means the training set is 20 and our training set is 80% and testing is 20%. So you can increase or decrease this data set also once you run this. After that, what you have to do, once you splitting the data into two training and testing sets, you have to now apply the model or fit the data. So here from sklearn library I am importing logistic regression, and with this I am model fit with the logistic regression. The model accuracy can be predicted with this command sklearn.matrix accuracy. You can, when you run this, you can get the accuracy of your algorithm, that is 87%. This is quite good. There is a term called confusion matrix which contains the different set. I'll explain the confusion matrix little bit in the coming lecture. So once we run this, we have this kind of confusion matrix, that is if it is 0 and predicted is also 0, that is actually 0 and predicted is 0, that is 652 cases are there. The actual is 0 and predicted is 1, that is 7 cases are there. Actual is 1, predicted is 0, 87 numbers are there, and actual is 1 and predicted is 1, that is 5 cases are there. So this might be a quite good confusion matrix. We can represent this confusion matrix also like this. This is the formula for true negative, true positive, false negative, false positive, sensitivity, selectivity, sensitivity and specificity. We can calculate it by this formula: true positive divided by true positive plus false negative, and specificity we can calculate it as true negative divided by true negative plus false positive. So this how you can calculate this also, and you can represent this how I'll show you. And for any logistic regression algorithm, these are very important to calculate, like confusion matrix you have to calculate, and the accuracy you have to calculate in any kind of logistic regression. Here I am using the simple print command to calculate the accuracy of the model, that is given by TP plus TN divided by TP plus TN plus FP plus FN. So this is the formula for calculating the accuracy of the model. Similarly, the misclassification accuracy is what we called 1 minus accuracy. Sensitivity, specificity, positive predictive value, negative predictive value, and positive likelihood ratio and negatively likelihood ratio. We can calculate it like this. Once we run this, you have the values for the different parameters as shown, and these are very important to represent any logistic regression algorithm. At last, in logistic regression there is a requirement of draw of ROC curve. I request you to learn ROC curve and also this confusion matrix in details with the logistic regression algorithms. So once you click this, we have ROC curve for this data. See, this is the ROC result where the true positive rate or sensitivity on the one axis and the false positive rate is represented on the another axis. See, at every step the sum of these two is 1, because false positive rate is nothing but 1 minus sensitivity, that is what we call. So this ROC curve is very important to explain any logistic regression algorithm. So One more thing we can calculate it here, that is the area under the ROC curves. Now let us see how to calculate this. This can be calculated by using this command sklearn matrix ROC under the curve, that is 73%. So 73% is reasonably good area under the curve. That shows the area under the ROC curve quantifies model classification accuracy. The higher the area, the greater the disparity between true and false positive, and stronger the model in classifying members of the training dataset. An area of 0.5 corresponds to the model that performs no better than random classification, and a good classifier stays as far away from that possible value. So whatsoever the value near to the 1, that is a good and ideal. So here in our case we have a area which is 0.75, which is closer to the 1, hence this algorithm is better fitted with the logistic regression. Hope you understand. So only thing to learn this logistic regression is you have to first of all read what is this ROC area, that is region under the curve, and one thing you have to cover is this confusion matrix. If you have a hold on this confusion matrix as well as on ROC, so you can apply the same trick to the various problems for logistic regression. Hope you understand this algorithm well. We will meet you again, and for your sake I'll put a link of whatsoever file I'll use here in the description box. And hope you like this video, and to see more innovative videos like this, and to get the practical exposure of machine learning, stay tuned with my channel. Till then, till the next video, stay tuned. Thank you.